electron volt. But if I'm not mistaken, this is not 7.9. You try to calculate it. I think this one got typo error. Okay. So Na plus Cl minus, you'll get NaCl plus 7.9 eV. Okay, because when I have one anion, cation, and I have one anion, this cation and anion will form the crystal. And when you form a crystal, you have to release the energy. Okay, so we have now three equations. The first equation, this 5.14, how we get it? You get it from ionization energy experimentally. And then this 3.61 is a electron affinity energy, also get it experimentally. Then the energy released when it forms crystal, it is 7.9 electron volt. I mean, this is not correct, I think got typo error. And how to get this value? You have to go through this electrostatic potential energy calculation. Then you get 7.9 or whatever answer is it. And then now you solve these three equations, you get the coercive energy is 6.37 electron volt. The property of ionic crystal. In an ionic crystal, the electrostatic bonding normally comes from the transfer of electron from alkaline atom to halogen atom, resulting in the bonding of positively and negatively charged ion by the Coulomb attractive force. The ionic crystal usually has high binding energy due to the strong Coulombic force between the positive and negative ion. Because no free electron to carry energy or charge, therefore they are poor conductor or for heat as well as electricity. Because of the strong electrostatic forces between the ion, they are hard and have high melting point. Because the strong electrostatic force means that the interaction between the atom and atom is very strong. That means it's very hard for you to dissolve the solid, or you want to separate the atom from one to the other. So therefore, you have high melting point, and then physically it's also very hard. But also because just now we see that the sodium have one valence electron, it has been donated to chlorine. So now sodium becomes sodium plus, chlorine becomes chloride. So now they have full orbital cell. When you have full orbital cell, that means that you have no free electron. When there's no free electron, that means that there will be therefore that means that this ionic crystal will not be a good electronic or heat conductor. Okay, so most likely it will be the insulator. Just now we have discussed the coercive energy of a pair of Na and Cl atom, right? A pair of Na and Cl atom. Now we know that in the solid state of the sodium chloride, the salt, there are many Na and many Cl in the solid state. Okay, so now the Madelung constant is a way to calculate the coercive energy or other energy, the Madelung energy, through the whole picture. The whole picture means that the whole unit cell. Okay, so the largest energy contributor to the coercive energy is from the electrostatic and also known as the Madelung energy. Okay, so this Madelung energy is the largest energy contributor to the coercive energy. Okay, that's why I say that just now. Previously, we only consider the coercive energy that involve Na and Cl atom pair. But now we want to consider that there are many atom NaCl atom pair in one unit cell. Okay, in one unit cell there will be 4. Okay, so we need to consider all the interaction between Na and all the nearest Cl, for Cl and with all the nearest Na. So how to do this? Actually not that difficult. So let's say I consider this red atom as Na. Let's say Na plus, this Na plus. So for this Na plus, it will have 6 nearest neighbor at the distance of r. Okay, let's say this distance is r. So you have 1, 2, 3, 4, 5, 6. Right, in 3D there will be 6 nearest neighbor. If you remember, if not, then you can go back to chapter 2. Okay, chapter 2 or chapter 3 to figure out how to find the nearest neighbor. So for this red atom, it has 6 nearest neighbor of opposite charge Cl. So if this is sodium plus, then the blue one will be chlorine. Okay, there will be 6 chlorine ion at the distance of R0. Okay, so this is R0. Then the next one, the second nearest neighbor would be the green one, right? The green one. And there will be 12 green atoms surrounding this red atom with the same distance. The distance is R0 square of 2. Okay, R0 square of 2. How to calculate this one? Basically very simple. If this is R, this is R, then this will be square of 2 R. Okay, so the distance between the red one and the green one will be square of 2 R0. And how many? The number will be 12. And the third nearest neighbor. The third nearest neighbor is the yellow color one. So the yellow color one, there are 8. The number is 8. If you don't know how to find the 8, if you don't know why the number is 8, then you can go back to chapter 2 lah. I've explained in chapter 2, okay, why the number is 8. And then the distance is square of 3r. Why the square of 3r? This is r, this is r, then this one is square of 2r. Then this is r. So here to here will be square of 3r. Remember? So the distance is square of 3r, and the number of the third nearest neighbor will be 8. And so on. And you can find the 4, 5, 6, 7, 8, 9, 10. But in this holistic physics, since it involves a very